Good morning, good evening, and good night, depending on which time we are going to observe this lecture. Welcome to this lecture. In this lecture, that is relating to the chapter states of matter. In this lecture, that we are going to discuss that is in continuation of our previous lecture. In the previous lecture, we have discussed the very important properties of the liquids, that is the surface tension and the vapor pressure. In this lecture, we will be going to discuss another very important property, that is the viscosity. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So today we are going to discuss the very important property of the liquids, that is the viscosity. First, let us understand what do we mean by viscosity. Viscosity is basically a measurement of the resistance of the liquids to the flow, and this has been arise due to the internal friction between the layers of the liquid. When the layers of the liquid that we have already discussed in the previous lecture, of course there is a very binding, there is a strong force between the molecules. Still, it is the liberty of this molecule to slip past with each other. So while they slip past with each other, at that time the frictional force, internal frictional force between the layers comes into play, and this is going to give the resistance to the flow where the liquid is flowing. So we can define the viscosity in this way. So you can define the viscosity. It is a measure of resistance. It is a measure So what is viscosity? It can be defined in this way. It is a measure of resistance to flow which arises due to the internal friction between the layers of the molecules when they are slipping past with each other while flowing. This is viscosity. And naturally, suppose we have to assume that liquid has been composed of the infinite layers. Suppose, that is, we can see so you can perceive that this is the layer of the liquids. One layer is above the others. In this way, you can say there is an infinite number of layers of the liquids, and it will have the molecules. So when there is a very high attractive force between the molecules of the layer, then what is going to happen? This will going to resist the flow. This will going to resist the flow, that we will discuss later on, how the viscosity is going to influence by these intermolecular attractive forces between the layers. And when the liquids flows, that you can easily understand that it is flowing to above a fixed surface, and the layers which is in contact with this fixed surface we can consider it as a stationary. And as the layer is the distance, it is increasing, the velocity of the layers is increasing as we go from the bottom layer, that is from the stationary layer to the upper layers. The velocity of the layer goes on increasing, and as the distance from the stationary layer is increasing. So you can understand there is a continuous increasing, we can say continuous gradation of the velocities. And this type of flow where there is a continuous gradation of the layers, velocity of the layers, we will call it is a laminar flow. This is called the laminar flow. This is a laminar flow where we can see that velocity of the layer goes on increasing as we move from one layer to the other layer. So let us now want to quantify the viscosity in terms mathematically, in terms say some parameters. This parameter will correlate with the viscosity, that is the speed of the layer and with the distance from the layer, and also will correlate with the cross-sectional area of this layer. Now we are taking one layer of a flowing liquid. Suppose this is a layer we are considering, and this having the speed is u. Speed of the layer is u. Naturally, the upper layer will accelerating this flow, and this layer, that is the below of this layer that we are considering, will retarding it. Why it is retarding it? Because the velocity is increasing continuously. This will be the lower velocity than this. This will be lower velocity than this. So suppose there is a increment of velocity of du. You can write this increase of velocity. Increase of, we will not say increase, we will say change of velocity. That will be more appropriate word. Change of velocity. Change of velocity, that is suppose du, and the distance between the layer, is suppose dz. So you can easily understand this is the distance dz, and if it is a u, then as this layer is accelerating this flow, so we will say this is u plus du, and here this layer is retardating this flow, means this layer will have this velocity of this. So what will be the velocity gradient? Velocity gradient, we know that for unit length of these layers, distance between the layers, how much velocity is increased. So we can write velocity gradient. Velocity gradient is equal to, we can say, du by dz. And suppose the area of layer is A. Then the force required to maintain this flow, suppose this is force is F. So at that time that will be proportional to the cross section of the layer. Layer having the cross section is A, this is also A, this is also A. And also we can see this is directly proportional to velocity gradient, du by dz. So we can combine these two equations. You can say A into du by dz. Here we will again put this velocity, this is proportionality constant, we will put that will be F is equal to this terms is called the velocity coefficient. It is a proportionality constant. This is called the viscosity coefficient. This is called the viscosity coefficient. Viscosity coefficient. Okay. So now we understand what is going to viscosity coefficient. This is the proportionality constant. Now we want to define the viscosity coefficient. Suppose A is 1 centimeter. Suppose A is 1 centimeter square. Sorry. A is square section is 1 centimeter square and distance dz is 1 centimeter and the velocity difference du, that is du is suppose 1 centimeter per second. One centimeter per second. So at that time we can see, we can put this value in this equation. What we will get? We will get F is equal to viscosity coefficient. So what we can write? We can write one thing, very important thing, that if the the viscosity coefficient, we can write this viscosity so we can write the viscosity coefficient is basically the force between the, it is a force means that is frictional force between the two layers, which is having the area of cross section is 1 centimeter square and the distance between the layer is 1 centimeter, to maintain the speed of 1 centimeter per second. Right? So we can write this is, you can see as n equal to, and this force is in dynes. The internal force that is being maintained as, it is in dynes. Understand what is viscosity coefficient. Now we want to discuss the units of the viscosity coefficient. This is cross sectional area, this is the change in velocity, and this is the distance between layers, and this is the area of cross section, area of the layer. Sorry, already we have discussed cross section area of the cross section. This. So we can write this equation, that is n is equal to, you can write F into dz by A into du. So when F is equal to 1, when F is equal to 1 dyne and dz equal to 1 centimeter and A is equal to 1 centimeter square and du is the 1 centimeter per second. At that time you can write this as 1 dyne into that is, we can write dyne into, that is centimeter, divided by centimeter square and centimeter per second. So at that time you can see, that is, you can write this dyne, this will cancel, so centimeter to the power minus 2, because it will goes taking in the, and centimeter, and it will be in the side, and this is called the 1 poise. So this is the units of the viscosity coefficient. This is the units of viscosity coefficient, or you can write this in this fashion, that is N is equal to, we know, force into mass into acceleration, and that is dz by A into du. So mass is 1 gram, acceleration is meter per second square, into distance is centimeter, and A is centimeter square, and U is centimeter per second. At that time what we will get, we will get this gram into that we will centimeter to the power minus, and we will get the second to the power minus 1. So this is also the another way of putting this equation, that is 1 poise. So this will be 1 poise, that is done this, and this will be this. What will be SI unit? SI unit for this viscosity is, you can write, that is Newton second, or you can write it is Pascal second, or this we call kg meter to the minus second. This is all SI unit. And what is the relation between this SI unit and poise? That is SI unit is 1 poise, you can write 1 poise is 0.1 kg Okay, this is the relation between this. Okay, now we understand what is viscosity, the units of the viscosity coefficient, and what is viscosity coefficient. Now, what are the factors which are going to influence the viscosity, that we are going to understand. Now we are going to discuss the factors that influence. First factor that is going to influence, that is the temperature. It was observed the per 1 degree increase of temperature there is 2% decrease in viscosity. There is a 1% decrease in temperature, 1% increase in temperature, there is a 2% decrease in the viscosity, and there is another formula that is given by Arrhenius formula, and it is viscosity is being governed by this formula. Here this is viscosity coefficient and this is the constant. This is called the Arrhenius equation. Arrhenius equation for viscosity, and here you can see this viscosity coefficient is constant, Rn constant, and that is EA. EA is basically the activation for viscosity, for viscous flow. Activation for viscous flow, and R is indicated as a gas constant and T is temperature. So temperature is the most prime factor, because when we increase the temperature, what is going to happen, the force of intermolecular force of attraction will going to decreases, and it will going to decrease the viscosity. Higher the viscosity means that is higher will be the resistance to flow to this liquid. Lower the viscosity, lower will be the resistance of flow to the viscosity. Okay, and that is all for today's lecture, and this is a conclusion, that is the concluding lecture of the state of matter chapter, and we have discussed all the points, all the subject matter in that is relating to your chapter, and let us have some recap of this. In the first lecture we have discussed about the very basic thing, that is why there is a different state of matters. It is basically the intermolecular force of attraction and the balancing of the other energy, that is the thermal energy. And in this regard we have discussed about different types of forces, intermolecular forces, van der Waals forces. Second lecture we have discussed about the most important state, simplest state of the matter is the gaseous state, and we have discussed about the two basic laws, that is the Boyle's law and the Charles law. In the third lecture we have discussed about the another two laws, that is the Amanton laws and the Avogadro's law. Fourth lecture we have discussed about the ideal gas equations. In this lecture, what we have found, we have combined all those gas equations, that is coming from all the Boyle's law, Charles law, Avogadro's law. And the fifth lecture we have discussed about the Dalton's partial pressures, that how we can able to calculate the pressure of the gas mixtures. The gas mixture means which is not reactive, which is not going to react with each other. In this case, how do we able to calculate the total pressure of the gas mixtures from its partial pressure, and we correlate it with the mole fraction also. In the sixth lecture, we have discussed about the Graham's law of diffusions. In the seventh lecture, we have discussed of the very important thing, that is kinetic molecular theory. How we can able to explain all the behaviors of the gas, that we have discussed. In the eighth lecture, we have discussed about the collision frequency and mean free path. That difference numericals also we have discussed. In the next lecture, we have discussed about the behavior of the differences between the ideal gas law and the real gas law. The next lecture we have discussed the liquefaction of the gases. It's all for today's lecture, and we will start the next new chapter in the next video. Thank you very much for watching.